In 1859, John Taylor published The Great Pyramid. Why was it built, and who built it? He was the first person to notice that the very simple 14:11 ratio inherent in the basic proportions of the pyramid revealed to an extraordinary degree of accuracy pi and phi. In the century and a half since Taylor launched this most significant quest to prove that the Giza builders had prior knowledge of higher mathematics, Egyptologists still deny there's anything more than coincidence involved. But in a moment, you're going to see for the first time that this seventh wonder of the ancient world has no less than 12 of the most important mathematical constants embedded within its basic proportions: the diagonal, the base, the half base, the side slope, the height, and the corner slope. Now, I'm using just the basic units generally acknowledged to be the original measurements the builders used in royal cubits: 220 half base, 440 base, 280 height. With these basic numbers, the side angle is inevitably 51.843, and these other measurements all follow simply by applying Pythagorean theory. Now, don't panic. I'm well aware that many people have the following reaction when confronted with mathematics. But I'm going to spare you for now. Everything you're going to see is documented in minute detail on a dedicated YouTube channel, so the true nerds amongst us can triple-check the math to their heart's content. The rest of us can relax, just enjoy the ride. So let's get into it. Here's the square root of 2. It's the only one that doesn't involve any proportion beyond the base, so by definition it's 100% accurate. Here's where we find pi. If we add these two diagonals, we get the Euler-Mascheroni constant. It wasn't discovered until 1734. What happens when you invert that? Square root of 3. This is square root of 6, square root of 5. Here's Brun's constant, not discovered until 1919, hugely significant in the field of prime numbers. Here's the Fibonacci constant, derived from a variant of the Fibonacci series. Here's the inverse of the golden ratio, phi minus 1. And here's phi itself from the Fibonacci series. Now, if we take the base and then divide by that phi, we get e times 100, close to 4 decimal places. And finally, here's e minus 1. Well, did you get that? Those 12 constants that we just found in the Great Pyramid are the exact same constants that Shakespeare embedded in the title page of the sonnets. Precisely. All 12. And bear in mind, he was also pointing us to the Great Pyramid by giving us the precise geographic coordinates. So clearly we have to look at the pyramid. What else is it telling us? If we stick a pin into the precise center of the Great Pyramid in Google Earth, it gives us this latitude to 7 decimal places. And if the Egyptians had built that pyramid 1 centimeter further north, or 1 centimeter further south, it would not be exactly this number, and this number is the speed of light in meters per second. 100% accurate. Shakespeare got it 99.999% accurate to 4 decimal places 400 years ago. How can he possibly do this? He has a method which involves the judicious placement of wrong page numbers in the first folio, the book published in 1623, containing 36 of his plays. It's got over 60 wrong page numbers, and every single one of them is part of a code. So, for example, it's known that the side slope angle of the Great Pyramid is 51 degrees and just between 50 and 51 minutes. Now, the very first page number mistake in the first folio occurs here. It goes from page 48 to 49 to 58 to 51? Well, obviously it should be 50. Note he's drawing attention to 50 and 51. What does he say down at the bottom of that page? Here, here, here be my keys. Ascend my chambers. These are called the ascending passageways, and they reach the king's chamber, queen's chamber, subterranean chamber in the Great Pyramid. Search, seek, find out. Now, we've just seen that one of the amazing characteristics of the Great Pyramid is it's built on the latitude that is the speed of light. Now, if we do a search in the sonnets for the word speed, we find it occurs in only two places, Sonnet 50 once and Sonnet 51 twice. Interesting. 51, 50, 51, the angle of the Great Pyramid. All right, let's do a search on light. That occurs in 6 sonnets, and those are the numbers of the sonnets. And we put these aside, and we're going to multiply the light sonnets and the speed sonnets and divide speed into light. And it gives us a number that is, frankly, unrecognizable. But he's not done yet. Do a search on the word pyramids. It occurs only once in sonnet 1, 2, 3. How brilliantly appropriate. So let's put the pyramid up there. Multiply those two numbers together and we still find something that has no meaning to us, but is working in the royal cubits that were used to build the pyramid. And then when we convert those cubits to meters, which I'm calling metra here, the Greek word for measure, the formula for that is to multiply by pi over 6, precisely, which is 0.524, and then we see the magic. It gives us this result, which is the speed of light to 99.84% accuracy. Now, the naysayers will say this is just an outrageous fluke. But no, he uses the same formula over and over again. He takes the sonnet numbers he wants to give us some calculation for, multiplies by the Shakespeare equation, which is always the same, the pyramid times pi over 6, to give the solution. So for instance, let's take distance Sun to Earth. I've already added up the sonnets that contain the word sun and the sonnets that contain the word earth here. Now, distance he only uses once in sonnet 44. So, multiply Earth by Sun, by distance, then by the Shakespeare equation, pyramid times metra, pi over 6, and the answer is this, which is the distance of the Earth to the Sun, to 99.994% accuracy. How about Earth to Moon? Same thing. To 99.9% accuracy. The formula is always the same, pyramid times pi over 6. It's an astounding accomplishment because he's working only with singular integers, the numbers of the sonnets. But he also gives us poetic clues in the words, in fresh numbers, number all your graces, to lend base subjects light in gentle numbers, eternal numbers to outlive long date. There's so much more. This is just a taste. There are more things in heaven and earth, Horatio, than are dreamt of in your philosophy.